tutorial will show how to use the generic scenario analysis to simulate any municipal solid waste composition. So the tool opens up to an instructions page, and then the user may proceed to the specifications tab where they can input any information they have about municipal solid waste. So the base case is the 2018 EPA municipal solid waste data, but the user can put in a custom set of data that they choose, and if they lack a data set in any particular category, they can just input 2018 data for that category alone. Additionally, we have a help button which provides explanations of each category and the different parameters in that category to help the user understand the information they're putting in. Finally, we have a basic version of this tool which takes the 2018 data and makes the calculations. The user only needs to input the amount of plastic that is recycled domestically, the amount that is incinerated, and the amount that is landfilled. For this demonstration, though, I'm going to do a full demonstration with the 2018 data. I will then click Calculate Streams, and we can proceed to the material flow results, where we see a Sankey diagram that shows the flows that are normalized, and then we can look also at the raw numbers that are used to generate this Sankey diagram and the flows based on the stream numbers. This data can also be exported to Excel. We can see this scenario visualized with different graphs that show the amount of plastic that is recycled and collected, and also the municipal solid waste composition. We can see the user input that was put into the entries before. We can also see the life cycle inventory, which shows the effects of plastic in different categories in the different stages of its life, from manufacture, use, collection and sorting, mechanical recycling, incineration, and landfill. We can do a scenario analysis, which examines how the mechanical recycling rate will impact the plastic additive releases and the releases to land and water. We can also look at the same under extended producer responsibility scenario, where we can examine the amount of additive that is released, and also how much mass is released to the land and to the water in both the base case and under the extended producer responsibility scenarios. Finally, we can look at the material loops, which assume that all of the plastic that was recycled, the additives that are in that plastic, are recycled into the next loop of recycled plastic, so we can examine the accumulation of additives throughout the throughout life cycles across multiple material loops.